First, a to the m over a to the n. That's just an example. I subtract my exponents. So it would be a to the m minus n. You're going to subtract. So in words, we say we are going to keep the base the same. Just like you saw on the one I showed you on the board, we kept it as 5, but we are going to subtract the exponents. And I'll use the same one that we just did. 5 to the 6th over 5 to the 2nd. Well, that would be equal to 5, and you do 6 minus 2, because you can cancel them out, and you get 5 to the 4th. Because not all of the problems I give you are going to be that easy, obviously. So if you have a fraction, and there's multiple things going on, simplify the numerator, which is the top, and the denominator, the bottom, separately first, and then do whatever subtraction you need. So if there's more than one thing going on the top or the bottom, deal with that first. Okay, some examples for you. First one. There's 12 sixes on the top. There's 5 on the bottom. You can cancel them out, or in other words, subtract. How many do we have remaining? 7. Right, so we just subtract. 6 to the 7th. Next one. You have 7 negative 2's multiplied on the top, 4 negative 2's multiplied on the bottom. You cancel them out. You have how many remaining? 3. Negative 2 to the 3rd you can subtract.
How come that doesn't go positive?
We are just simplifying the exponents. You're not evaluating. So make sure you leave that in parentheses. We talked about yesterday how if it's in parentheses, you got to keep it that way. Next one. This is where I'm talking about if you have more than one thing going on in the numerator or denominator, you have to simplify that first. So on the top, think what we did yesterday. If you have the same base and multiplication, what do we do with our exponents? Add. Okay, so on the top, we need to add the exponents. So in total, we have how many 4's multiplied on the top? 4 to the 10th over 4 to the 4th. And now you can go ahead and simplify that. Same base and division, you're going to do what? Subtract 4 to the 6th. 10 minus 4. Because you're canceling out 4 from the top. Okay, last one of this kind. First thing that you need to do is actually multiply these fractions together. But the second one's not a fraction right now. Guys, how can I make it into a fraction? Put a 1. And when we multiply fractions, you multiply straight across. So this is the same thing as y to the 12th, because we're just multiplying by 1, over y to the 9th. Now you can simplify it. That's going to be y to the 3rd, subtract.
What happens to the 1?
So 1 times anything is just the thing itself. So 1 times y to the 9th is just y to the 9th. 1 doesn't do anything to it.
Well, it feels like a 3.
The what?
If it was like a 3 there, it would be like 3 over that. Final.
Yes, if there was a 3, you would keep it. But there's not. Okay. Next rule is similar to one we did yesterday. Okay. This is power to a power, but with division. So it's pretty much the same thing. I'm going to write it with the letters first, and then we'll put it in words and do an example. The letters, if you have something divided, taken to a power, then you just multiply the power to both things. So since those both have an exponent of 1, a and b, it would be a to the m over b to the m, or the mth. So same thing as yesterday, you're going to keep the base and multiply the exponents. So these notes, since we're going to be adding new rules every day, so make sure you keep your notes handy this unit, because as I add more and more, it's easy to forget. I'll also put up a poster on the board. I have one somewhere in my closet. So an example of that, say we have 3 halves to the 5th power. Both 3 and 2 have a power of 1 right now. If you don't see it, it's a 1, and so we just multiply the exponents. That would be 3 to the 5th over 2 to the 5th. Just a couple examples, and we're done. Give me a second, I'm moving slow mo. Okay. Simplify the expression using the power of a quotient. So this is power to a power again. R and S, you do not see an exponent, so what exponent is there? 1. Just like yesterday, multiply your exponent to both. So it would be R to the 5th over S to the 5th. And that's it. These are not the same base. R and S are different bases. You cannot try and subtract those. Don't let me see you do that. You will make me sad. These are not the same base. You have to leave them separately. Last one. So you have 2 things here. You have -4. We'll put the negative with that to the first. And you have W to the first. So put that negative with the 4, and we're going to put it in parentheses. Because it is in parentheses right now, you better stay that way. So when you write this out, it needs to be -4 in parentheses to the 3rd over, we're multiplying our exponents, W to the 3rd. Okay, but if you remember we talked about yesterday, when you have a combination of bases that are normal numbers and variables, you have to go ahead and evaluate the normal number. So -4 to the 3rd, we're going to actually figure out what that is. -4 to the 3rd would be -4 times -4 times -4. Now before we even multiply it, you have an odd number. So will it turn out to be positive or negative? Negative, okay. So, and you can, if you don't remember that rule, it's not a big deal. Just multiply and see what you get. -4 times -4 is what?
16.
Positive 16, and then positive 16 times -4 is -64. Oh, it's the same one we just did on our warm-up. So -64 over W cubed is your final answer.
Yeah, just do like the 3rd half.
It's the same thing. We'll have a quiz